Morning, everyone. Good morning to all the participants and our today's speaker. So, I welcome you all to this fifth day of this nation level AICT ATAL sponsored faculty development program. And our today's first speaker is Mr. Manoj Agarwal. He's an alumnus of MBM Engineering College, Jodhpur, and currently he's working as a technical delivery director at Mokxa Technologies. So before we start the today's session, I would like to invite my colleague Ms. Geeta Kumari to give a brief introduction to our speaker and then we'll start. Ma'am, please take the stage.
Thank you, sir. Good morning, all of you. So it gives me immense pleasure to introduce our next speaker, Mr. Manoj Agarwal, sir. Mr. Manoj Agarwal is an expert in strategy and technology governance and architecture frameworks. He is a technical delivery director at Mokxa Technology USA. He has more than 20 years of industrial experience where he has worked with IIA, EII architecture with DDS, DWS, and DM in the financial and healthcare and telecom industry. He has completed his MBA in Information Technology Project Management in 2014 and MS in Database System and Technology in 2013 from University of Maryland. He has completed his graduation from MBM Engineering College, Jodhpur. Now, I welcome Mr. Manoj Agarwal, sir. Sir, please.
Good morning, everyone in India, Australia, and those regions, and good evening to all my colleagues, attendees here who are participating at this odd hour from US. Let me ask you, are you able to hear my voice and have a video on clearly? Are you able to hear me loud and clear?
Yes, you are clearly audible. And also we can
Okay,
see you as well as your slides.
very good. So, first of all, thank you very much for providing this opportunity to share my experience and knowledge regarding the artificial intelligence on big data analytics platform that I've been working for last 2 decades. This is one of my passion that I've been fortunate to work on business intelligence area in the beginning, and then obviously in the year 1999 onwards, and that culminated into lot of analytics areas like big data and artificial intelligence, machine learning, deep learning, etc. So let me go ahead without any pause here. Um, Let me know if you're able to see my second slide. This is my profile as mentioned earlier. I am an alumni of MBM, Computer Science and Engineering. And my expertise is in ML, machine learning, AI, and deep learning. I've worked in the past in GE Energy Atlanta and GE Oil and Gas in Florence, Italy. I have worked with Capgemini America as a consultant to AT&T Atlanta and then Disney Studios. I have worked with health insurance companies, 2 leading health insurance companies, Blue Cross Blue Shield of Maryland and Kaiser Permanente in Maryland. From my educational perspective, I completed my master's in IT in database systems and then MBA from University of Maryland. My personal interest belongs to, I am a spiritual and evangelist. I love reading Bhagavad Gita, Vedas, and Upanishads and discuss on those topics. I am also a real estate entrepreneur with some community service. Interested in astronomy, aerospace, and relativity theory as my son is going into that area soon next year. Okay, so moving on to the agenda for today, our today's presentation will be divided into 3 parts. The first part will discuss about some common terms and terminologies and concepts around human intelligence and virtual intelligence, how evaluation of AI happen, what is pattern and cognitive learning. We'll discuss about importance of data into AI world, and then how big data help develop AI, what is the relationship between AI, ML, DL, and big data. And then we'll also discuss about the catalyst for the change that was a big data cycle. So we'll spend initially 30 minutes on these items, very important. Then we dwell into industry use cases and implementation. These are industry use cases that are being implemented in my company on various clients. We'll discuss first the health insurance use case for risk score and analysis. In healthcare industry, what does hospital readmissions mean and how hospital readmissions can be reduced using AI and big data. The third use case is about healthcare, how in mammography the cost can be reduced by eliminating positive false. We'll discuss about marketing, the campaign analytics, and finally about finance industry, about credit card fraud alert system. Having discussed about the industry use cases, we'll go into the drawbacks of AI and big data. Not everything that looks green is good. So in AI and big data, there are certain limitations that we talk about that, and we end up the session with questions and answers. So this is how the program is structured for next, 1.5 hours to 2 hours that you will be with me. We'll go with the monologue session of explaining you session 1 and 2, and then I will open up for questions in the last 30 minutes of the session. During the session, if you encounter any questions that you need clarification, you are welcome to type that on a chat box. So you don't forget that, and we will take those questions at the end. I also want to introduce along with me one of my colleague. He is Ravindra Shukla. He is a IIT Bombay alumni. He is a expert in AI and ML and have implemented various US companies. He was part of PwC and IBM in the past, and he is here to share with you during the question answer session anything that you require and deep expertise or you need exact how things are implemented. So he will be able to help us and provide clarifications on those directed questions. Let's move on to the first slide. So when we talk about artificial intelligence, the very thing that come into our mind is human intelligence, because the intelligence word was related to human being, animals being having very limited intelligence. So what is human intelligence first? Let's dwell into that. Human intelligence normally refers to the human's intellectual capability, the way we think and the way we try to learn things through our experiences. And when there are complex concepts, we apply logic to those experiences and reasoning. We solve the mathematical problems, we do recognize patterns, and then from those patterns, we try to retrieve the knowledge that is hidden in those patterns. And then we make inferences and then take decisions. We do communicate with our intelligence with other human fellow beings. So that is the basic definition of a human intelligence. Now, how artificial intelligence came into picture and how it is related to human intelligence. As we know that human intelligence is a branch of data science that actually focus on building smart machines. And these smart machines we are building to mimic what human intelligence can do. Now, we are also building these smart machines to not only mimic, but to also outperform what humans can't do with the capacity that we have. So definitely the smart machines that are built will be performing wide range of tasks that normally require human intelligence and cognition. These intelligent machines are imbued with learning from experience and historical data, analyzing their surrounding environments and performing the befitting action. Um, Abhishek, can you help? People are sending me messages to admit into the call. If you can admit them, please. Okay, we'll move on to the second slide, which says what human intelligence, what makes us unique, and is that we are backed by abstract emotion. Like we have self-awareness, we have passion, we have motivation. This is not available when we talk about machine intelligence or artificial intelligence. For example, if I may ask you that if, in school days, we were taught that if there are four animals in a room, and then if you add two more, the total will be six. That's a simple logic. But behind this logic, there is an underlying assumption that we are using a mathematical computation called addition, and also we know that there are entities inside the room which are animals. Now, if somebody tells you that there are four rats in the room, and then you are adding two cats in the same room, then can you tell us how many total animals are there in the room? Now, each individual will say different answer based on different assumptions that they can take. So that brings us to the definition or the concept of cognitive learning. What it means is our answer depends on the assumption that we make. If we use our mathematical brain, then obviously we are saying that there are six animals in the room. But if we use human brain with cognitive analysis, then we say that there are only two animals. That is one type of animal is a cat, and the other type of animal is a rat. Similarly, in this picture that you see here, you see there are four fish here, and then obviously you can call this as a large fish or this is a whale. That is not equivalent to five fishes. And if we talk about patterns or additions, 4 plus 1 or 4 plus I is not 5. What it means is, why we are talking about these concepts is artificial intelligence or machine intelligence is totally dependent on the data and how it interprets the data. So the same data can be considered as animals versus rats or cats depending how the model is trained. So the artificial intelligence sometimes can give you wrong results depending on the model that you train to. So that comes to a concept in AI or in analytics that we refer to as rule-based learning versus data-based learning. So a data-based learning in AI simply means that you are feeding a raw data, without any context, and your model that need to devise the logic behind it and then generate a program or an algorithm for that. Now, a rule-based learning means you have an assumption for a rule that you know that you are putting on the data. Example, rule-based learning simply means example is addition, subtraction, multiplication. If we say that we are going for multiplication, there is a rule that rule is repeated additions is multiplication. So that's a rule-based learning. Second is pattern finding. Now, pattern finding is one of the use cases in AI where which is implemented in image processing. This is a vast area and also important because prior to artificial intelligence, images were not considered to be part of computer and analytics. They were just data storage entities. We used to store data as an image, and no intelligence can be retrieved from them because of absence of computing power, or absence of scalability that we have achieved in the past on AI. And that is referred to as cognitive way of processing the data. Basically, now the data is not only processed with just as bits and bytes, but the data can be processed in an intelligent fashion. Again, it brings to a very important aspect of this. No matter how good we build our models, those models will be as good as what we provide the data. And that's why I will touch upon that in the later half of this presentation, that instead of feeding data, if we feed information into our model, the models will be much better. So that's a distinction between database model versus information based model. Okay. Let's go into how AI came into play. When did AI started, and how big data played as a catalyst to AI. So, as we know, data as such existed for decades and decades since the computer was invented. Now, big data came into play, and I'm not going to go with the definition of a big data. I think those are the basic concepts that you might have covered in the past 4 days. But what I will cover today is how big data plays an important role in AI. So in order to understand the role of a big data in AI, we need to understand how AI evolved, from where it started. Now, the artificial intelligence, if you think, it was always present from the antiquity. Since we were, a child, our parents and our teachers used to tell stories about certain myths and inanimate objects that were endowed. Uh, we used to think about those stories as just stories because they were never thought to become real. But in the seeds of modern AI, however, were planted when this thought process came into place with philosophers. They're trying to think, and when they were thinking, they were actually thinking that such kind of systems, intelligent systems, will become a reality in future. So this all came into play in 1955 when a person called John McCarthy, he was a computer scientist in at a Dartmouth College, which is a private Ivy League college here in US in New Hampshire. A conference was established, or a workshop was established with eminent leaders and scientists in that era to discuss particularly about neural networks. So neural network did existed in 1950s. And why it existed? Because they thought how human brain work and how they can convert that human brain functionality into a machine functionality, that a machine can perform similar to what human brain can perform. I'm fortunate to retrieve this, this picture from Dartmouth, which is this is kind of the legacy. These five people that you see were attendees of that first conference that happened on AI in this world. So all that started, but then why big data and AI come into play? When we talk about computational power, there was limited computational powers in early 70s, 80s, and 90s. And obviously the Moore's law come into play, where there is a limitation whereby the transistors can be placed on an integrated IC. How many number of transistors can be placed? Obviously, the transistors are equivalent to a byte of storage. The number of transistors, are equivalent to that. So that's why, because of that technological limitations, AI was restricted only to the research lab till 1970s and 80s. And hence we call that as a 6 decades of AI, meaning the machine learning became more popular only after 1980s, and then right now around in 2010 onwards. Funding for AI actually peaked in 2000s as major tech giants began building supercomputers to invest in AI. Deep learning became the focal point of AI research around the world. So if you see this picture, 1950 to 1970, neural network was into the game for AI, where research scientists were using neural network to design the thinking machines. Then in 1980 to 2010, machine learning started become more popular. Right now, we are into the era of deep learning, which is a subset of machine learning, but with advanced tool set and algorithms and set of data. So that's how the AI all got started. Now, how big data plays into this game? As I discussed in the previous slide, the big data come into play around in 2010 to 20, around 25. My first instant with big data was in 2003 when I implemented the project at one of my client in a healthcare vertical. That was in 2004-2005 period. Uh, this big data come into play where we said that we require data set with these 5 V's: the variety, volume, velocity, and veracity and volume. Veracity and value. So for artificial intelligence, we require particularly the velocity and volume and variety of data. And this was not present prior, where big data concepts were evolved around in 2005. Artificial intelligence was in a very limited fashion used with limited set of data. So again, when we talk about big data, it is the distributed parallel processing, uh, which enhance the infrastructure. The cloud computing at the same time uh, proved to be the game changer for the industry, and this is where all big data and AI come into play. Now, I have seen people using, and sometimes me too, my fault. People use this terminology AI, artificial intelligence, machine learning, deep learning, and big data interchangeably. How, and of course, the data science as well. So how they are related? Let's spend a minute or two on this. How they are related to each other, what encompasses, and how they are used with one another. So if we talk about artificial intelligence, we are talking about tools and technologies that involve not only machines, but it involves the variety of data sets, that is big data, and which also involve the advanced tool sets and algorithms, which is deep learning. So artificial intelligence as such is the overall abstract form of concept that we are talking here. Within artificial intelligence, then machine learning belong, which is a subset of artificial intelligence, which include the use of machines for providing the advanced analytics. An example being Google Maps being used for traffic, Facebook facial recognition that use machine learning, Netflix video recommendation. If you use Netflix, you see that it provides you recommendation based on your previous experience or previous viewership that you have used. That's machine learning. The deep learning is again a subset of machine learning, which is a part of artificial intelligence, which involves low volume of data, but it involves a high set of algorithms used targeted for specific purpose. One of the drawbacks of machine learning was it uses high set of data, which sometimes are not available. And when you don't have a large volume of data and you have a smaller sample set, then deep learning is the choice. Now, how big data and data science come into play here? Big data is just a vehicle, I will say, that drives this artificial intelligence, machine learning, and deep learning. So it's the mechanism to provide 5 V's to uh, to the problem that you're trying to solve. And data science is the overall intersection between big data, deep learning, machine learning, and artificial intelligence. So if someone talks and tell you that he's a data scientist, then we expect him to understand all these concepts in totality. So this is how AI, ML, DL, and big data are interrelated, correlated with each other. Now let's quickly go into how AI is useful in various steps of big data cycle. A big data cycle involves 7 different stages: data management, pattern management, context management, decision management, action management, goal management, and risk management. In each of these areas where big data uh, get involved, AI plays an crucial role in not only acquiring the data. For example, when we talk about data management, we are talking about acquiring, validating, storing, protecting, processing, and processing the data. Now, big data tools and techniques does all this. That's the first step in our in the data present in data cycle. Now, AI, when we talk about AI, what AI does is it facilitates the acquisition or validating the data set. For example, when we talk about pattern management, so it monitors pulse on incoming signals and events. So image processing, for example, is the right use case for pattern management. Context management is the understanding of data and how often change with the context we can view through which the outcome is changed. Now, what it means is um, not always, as I explained you in the previous on the first, second slide, when we are talking about fish and animals, there is the context that is very important to leverage to 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 have the right outcome. So the type of the data that is there, which is attached to a context, if we don't have it, that means it is having a raw data. And as I said earlier, AI is then as good as our data, which actually becomes raw data now. Decision management cycle: designing, building, and managing the automated decision making systems for internal and external use. Example being, if you use Amazon, it gives you and facilitate you to choose the right product. If you go to Amazon and you are purchasing, for example, you normally purchase things of sports. So Amazon immediately understand that you are a sports enthusiast, and within sport, if you purchase golf items, then it understand that you you are interested in golf, so it gives you an ability and show you the preferences on the products as what are the right product for you to choose. Action management, again, it provides you the ability to take right proactive action and reactive action. This is particularly important in healthcare insurance companies or healthcare. Based on your disease score, health score, or your members health score, the companies take the action to take the proper care of the health of most diseased people. Goal management. Goal management involves achieving various goals, and this involves bots and managers. These are like, you know, the artificial intelligence is used to conduct the bots. Finally, the risk management. Risk management is used in every cycle, everywhere, where you want to minimize the use of resources, and you want to minimize the impact and threats to the society. As I discussed, this is a similar concept. The biggest thing for AI was the big data, and how the big data actually became the catalyst for the factors that were driving the change. The very first thing was cost. Why cost? Because prior to big data that come into existence, we were using supercomputers, which are very, very costly. It takes the scaling of the infrastructure takes high cost. And as you know, the big data, when big data come, we use appliance meaning those systems were distributed systems, low cost systems, and the appliance hardware. So the cost plays a very big role in the in the popularity of artificial intelligence. And why the cost become? Because big data costs got reduced. The second thing is about cloud. When cloud computing come into existence, it increases the flexibility, collaboration, and the cost efficiency. And obviously that flexibility provided the ability to our customers to give them an edge towards their competitor, to develop more products which they can change quite frequently. The third is about the external data. External data simply means that we are if we are able to now get data from multiple data sources. Talk about Facebook, external data from Twitter, talk from cross platforms like sensors. All that data can be all combined together, and that actually becomes the catalyst for artificial intelligence. Now, why we say that? If you talk about human intelligence, we can interpret pictures, we can take sound, and we can listen and we can interpret that. We can see the letters or languages. That's how all different kind of data humans can consume. Unless a computer can consume a similar kind of variety of data and external data sets, artificial intelligence cannot become in par to human intelligence. That was the one of the driving factor for the popularity of artificial intelligence. Volume was another one. As you know, human neurons can take like petabytes of information. We can store so much information, and as such big data as well. So artificial intelligence, again, because of volume of data that can be supplied to different tools and technology, artificial intelligence become very popular because of that. Digital, again, the digital, when we call digital, the digital landscape increase the processing of AI as well. And finally, the complex decision model, in which we say that disparate large volume of data sources that used to take, you know, overnight, when during my early days of data warehousing and business intelligence implementations, all projects that I have worked in the first decade of 2010 on, it was an overnight processing. So used to take like 6-7 hours of data crunching, and then the reports will be generated after that. Now the decision model used to take like it was a daily reports or sometimes monthly processing. With the advent of large volume disparate data sources, this all has become real time now. Okay, this has come to our first set of presentation today, which was about various concepts of um, big data. And we talked about these 6-7 areas. If anyone has any questions on on these 6-7 areas that we talked about, interrelationship bit about AI, ML, and DL, they are welcome to write those questions on the chat or note it down, and we'll take those questions in the last half of our session. Let's go into the second part, which is one of the most interesting area, and my choice is to share with you all the industry experience that I have gained and my partner Ravindra Shukla has implemented. We will share with you about these 5 use cases and how businesses they were get benefited out of that and had a competitive advantage over their peers in the market. So let's go for the first one. The first use case that I'll be taking today is in the health insurance sector, healthcare insurance, and that's about health risk scoring. What health risk scoring means is, I want to give a number, a risk score, to every person in the world, how healthy they are. And to my surprise, Google Brain is one of the one of the concept or tool with Google that they are defining now how long will you live. So what it means is they can clearly, obviously define that your age will be this much, and obviously there is an abstract form, no one can tell exact age, but they are very close to that. So what it means is we take the we take the data about patients demographic information, we take the data about patients claim information. The claims contain information about whether they were treated for any diabetes in the past, they were treated for any heart conditions in the past. All that data is collected, and then it is called stratification identification in healthcare terminology. So this results in a better stratification for care management for the patients, and then better identification of patients with which we can then put more focus on their care. As you have heard about 80-20 rule in almost every industry, 80% of the insurance cost is spent on 20% of the patients. What it means is only 20% patients are so unhealthy that they eat up 80% of the premium that is collected from all the members. So this comes to a conclusion that why can't we focus all of our resources to take care of those 20% members? This is where deep learning comes into play. Why? What deep learning has done, we combine the credit card data and a bank data with the health data. And this is done in a real fashion in my previous implementations, where the credit card data, and what credit card data has. Suppose a person says that they are non-smoker and non-drinker. Okay, our doctors used to believe them. But when you really see their credit card statement, you find that, hey, they are going on a liquor shop every week to buy liquor. If that is the case, buying a liquor, I'm not saying that they are necessarily drinker, but if they are buying, there is a chance that someone in their house, most probably they are consuming it. So we combined that kind of data, healthcare data with financial data to get the deeper analysis about a member behavior. Um, that kind of data, if we collect that, generate a predictive risk model for patients. We use past data to predict the cost of patient's care. Example, if I have out of 100 members that I am giving insurance, and out of this, say, 60% of my member are unhealthy, then obviously my business model will incur a lot of cost and there will be a loss to the company. So what normally health insurance company does is, it's called health risk assessment and scoring. Before they take any member to give insurance, and now you might have heard about that insurance companies deny insurance to very unhealthy people. They don't give insurance because they know that they will be incurring cost on them. So all that information comes from underwriting, which uses this health, AI and deep learning techniques. How this is done, let's go into a um, deep dive into this. So the very first thing is the standalone data sources. So what it means is, we collect data from claims data, the past data that comes from their health insurance claims. We collect lab data. We collect demographic data, where they belong to, which zip code they live, what income level they belong to, etc. All this data is integrated from disparate sources and combined into a platform, now a big data platform. And then those data, once they are combined, key information is retrieved from them. That's called key data. Key data, ICD-9 is called, this is the nomenclature used in health insurance sector. CPT codes, ICD codes, these are codes used to denote some disease. Every disease is coded with a code. So all the data, key data is retrieved, and then a modeling technique is generated using under the direction of that particular company's subject matter expert. They know how the key data influences their business. I'll give you what the key data factors are. Key data, for example, are their BMI, their cholesterol level, their diabetes, which is cholesterol level, their heart condition, and their past disease conditions, if they have any chronic disease. So there are 5 total, actually. Here are there 5, which are blood pressure, blood sugar, BMI, cholesterol, and tobacco use. So those are the 5 key data entry points that are collected and a model is generated. Finally, the tools and technologies available like Hadoop, SAP HANA, those were used in our projects and companies that I have been in to generate a real-time score. So a person out of 1 to 10, some companies use 1 to 100. If we say that his score is like 10 out of 100, then he's a risky patient, very unhealthy. If a score is 80 and 90, that person is a healthy person, a person which was welcomed in a health insurance company. So this is the implementation methodology used. So you take the source tables, you push that data here into the master data warehouse. You move that data into your model, and then you generate those key parameters out of those models. You combine that data along with the external data. Finally, you calculate the points using 5 biometric points using HANA. You move that into the platform of AI, those 5 key points into AI, and then you generate this dashboard or a Lumira ad hoc analysis or insight. So these are presentation layers only, but the combination of all these were involved in generating the risk scoring. This slide tells you what are the parameters that are most crucial when you collect the data. When you collect the data and perform an AI, then you come to know that age is one of the crucial parameter. Then diabetes, then zip code. What it means is if you're living in a particular state in US, then you may be you may have a potential to generate certain kind of diseases. These are zip code pattern areas. If you belong to any occupation, example, you belong to mining, then you have a risk score which is kind of risky in the area because you are in the risky job. Okay, so that's about risk scoring. We'll go into the next use case, which is hospital readmission. Before we move into that, so the risk scoring is all about rating a person whether that person is high risk or not, and then based on that, business decisions are taken. Hospital readmission is similar to the risk scoring, but here what we do is we take parameters like these 5 parameters, and then we have a regulatory agency in US which is called CMS, Center for Medicaid and Medicare Services, which define or put penalties on hospitals and health insurance companies anytime if there is a readmission that happen. So for example, if a person was admitted and then he was admitted because of heart attack and he was released from the hospital, and then 5 days or in 20 days he come back in hospital, that should not happen. So there are penalties involved, and those penalties are financial penalties that companies has to incur. So in order to avoid those penalties, this AI solution was put into place. These 5 different types of conditions on which penalty was involved: heart attack, congestive heart failure, asthma, knee surgery, and hip replacement. Current rate, we know that for readmissions is 17% in US, out of which 76% can be avoidable. And the way it is done is we identify the high risk for readmissions and then bucket them into 0 to 30, 30 to 90, and no admissions. How this is done is, very first thing is when we collect the data, and in AI, it's very important that you recognize if there is a missing attribute or a missing data in a record. If that happens, you either remove the record or you fill that record with mean, median, or most frequent based on health score. Then you categorize the data, what kind of data it is, and mostly numeric data is used in AI. So you have to convert your other forms of data into numbers. Then you scale your data. Scaling means you cannot have age and income at parity. Age is between 0 to 100, but income can be from 0 to 1 million. So when you are combining your point A and point B, then you have to scale them and bring them all in at one level between -1 to +1. Meaning, if you say that somebody's age is 70 years, but his income is $700,000, those are at the same level. Now you have Now your data set is at the parity of 0.7 each. Uh, then data sources, what we did is for this project, multiple data sources were used that provides you a variety of data. So um, hospital ERP system, which is called Epic. Epic is a vendor that generates that has a product which is mostly used for hospital management, that contains the encounter data, that when a person goes to a hospital, diagnosis and procedure data from medical claims, lab data, different kind of data. Within that data, then you define attributes that you're interested in, and then we have used these Python libraries which are open source, out of which sklearn was the most important one that we have used, using Python libraries to for AI. And next one is to building the model. So I will not be able to discuss with you all the models here because of lack of time, but out of various models that we tried on this project, the two that we selected was for the support vector machine, and we also selected for the another one for deep learning, which is TensorFlow. So TensorFlow is used using the neural network. This is the architecture for the this is the IT architecture, I will say, what kind of technological layers that were used. So on below you see this is all Hadoop infrastructure, SDFS scoop, Hive data warehouse, Impala Spark in memory analysis, Kafka for streaming analytics. Here are the sources that I just discussed with you, and these are ingested using ingestion layer. Data lake was created, modeling layer was there using Spark and ML algorithm, scoring layer, and finally the visualization was produced that provides the ability to the companies to make decision. Okay, so that comes to the second use case for out of 5 that we are going to discuss today. You are welcome to write your questions on the chat for the hospital readmission, and if you want to ask any specific questions regarding modeling techniques that we have used, we'll be able to answer that in our question and answer session. Let's move on to the let's give a break here. Just I want to check with with everyone here, or maybe Abhishek, my voice and video and everything is all clear. Any concerns on that? Okay, very good. I just want to say sometimes people keep on speaking, don't know that their connection got lost. It happens in online systems. Okay. So the next use case is about the third use case, and this we have. This is one of the use case done in Kaiser Permanente Health Insurance Company. They participated in this research. I was not directly involved in this, but I currently work with Kaiser Permanente, and our team of healthcare professional practitioners was involved in this research-oriented project. So let me tell you about the what problem we are trying to solve with mammography and radiology here. So currently in US, what happens is all mammograms are done using are analyzed by radiologists. So they take the mammograms, which are images like X-rays or MRIs. They identify lesions or any unusual features which are present that indicate cancer, breast cancer. 40 million mammograms are done in US every year, out of which around 9 to 10% patients are asked to come back because they are suspect. The radiologists see that there is something wrong in their mammograms, so they call those people back for further screening. When these patients, 10% patients come back, it was identified that out of those 5% patients are then diagnosed with cancer, and other 5% are sent back as healthy. What it means is there are false positive. So these false positives lead to unnecessary tests, or even sometimes, cancer treatment are started on them with false positives. And the cost that is attributed to the false positive is $10 billion every year. So the objective of this problem, or the challenge that was there, was to develop an AI algorithm, or not just AI. It was asked that what can be done using technology that is in hand to use this image processing so that it can aid the radiologist to take an informed decision and have a predictive accuracy of digital mammography. So a dream project was established in 2017. The dream is Dialogue for Reverse Engineering Assessment and Methods, which was organized by Sage Bio Networks, by IBM, and Icahn School of Medicine, which is present at Mount Sinai, and Kaiser Permanente, Washington Health Research Institute. So these four entities partnered together to propose a challenge, or they actually proposed to 1,100 scientists across academia, industry, government, across 44 countries to come up with a proposal. So different teams participated, and they brought back an open source machine learning algorithm to improve mammography interpretation. So how does my company and our team participated in that? Kaiser Permanente, we are one of the largest health insurance companies in US which has substantial healthcare data. Kaiser Permanente is in business for last 80 years, and hence it's a big data set that we can supply. So what we did is we supplied 144,000 screening images of mammogram. Obviously, because of personal health information, we provided anonymous data with removed all PII data from it. From 80,000, these were from 80,000 people, and 952 breast cancer patients. Images were then linked to the data on risk factors. Like, the risk factors were defined by a consortium which is called a Breast Cancer Surveillance Consortium. It is a national network of healthcare professionals will define what are the risk factors. We combined all together, and then top 8 performing teams were selected to build the model. Finally, what was the conclusion for this mammogram graph project? What was identified was not a single algorithm by itself is sufficient enough to give or aid any help to radiologist for mammograph interpretation. So we have to combine multiple algorithms and choose the best out of best logic out of all those, and then have a single radiologist assessment done will do to improve the accuracy. It prevented 500,000 Americans from having unnecessary follow-up tests after an annual screening mammogram. So prior to this solution, as we said, there were false positive. So these false positive, about 500,000 patients were avoided or asked to come back for secondary screening. So adding AI to current US mammography practice improved breast cancer screening performance. And when you do that, it reduces the cost of a healthcare. and obviously it relieve radiologist workload. Now they can focus more on radiological in findings rather than trying to see deeper into the anomalies on x-rays and MRIs. Along with the mammograph, I want to cover some quick healthcare implementations that are done by us here in the current company and in the past company in last 2 decades. Back in 2014, it was identified that the US health insurance, not health insurance, healthcare business is approximately $150 billion that will be saved for implementing data analytics, BI, ML, or AI solutions. And it was targeted that between 2014 to 21, 150 billion US dollars will be saved. It's a reality now. And as we see in this beautiful pictorial illustration, what are the various areas where these savings was done? The very first saving, as we see, is done on robot assisted surgery. The robot assisted surgery is a common phenomenon currently in US, particularly done in brain surgeries where high precision surgery is required using image processing. So image data from the brain is collected and fed into the system to perform these robotic surgeries. The second areas of implementation is about virtual nursing assistants, which are quite common now in India as well. When you go to any website, you see a chat person pop up. Many people think that chat person is a real, but IT implementers know that those are bots that are intelligent enough to understand your questions and then react based on the questions and provide recommendations. So those chat bots helped reduce $20 billion of cost of human resources that were involved in the past. Administrative workflow assistant, this is a claims workflow whereby claim processing was done manually when there is any failure on claim processing, so that was also reduced. Fraud deduction, um, very interesting concept here in health insurance company where some of the health providers submit fraudulent claim because nowadays all claims are processed electronically and the money is EFT'd or automatically debited to a doctor's bank account without any human intervention. So when this has happened, obviously it's fast processing, but it has a drawback. So the drawback was, some of the providers were submitting, the claims which were not they had not even seen the patients. Those are fraud claims. And when that happened, the AI comes into play where it can detect anomalies in the data. A biggest anomaly, for example, I can give you is a drug which is meant for a female patient is noted down on a healthcare claim to a male patient. So that rule is built by AI by seeing the past data stating that, hey, that particular kind of medicine was always given to ladies. It means that that particular medicine is meant for them. But if any claim that comes in future, and if it's a fraud claim that a doctor has just, without seeing the patient, just jotted down any random medicine, and because they jot down any random medicine, they do this mistake. So this kind of fraud detection is a reality now using AI, machine learning, and big data. Dosage error reduction is another area where um, you know where unnecessary medications were prescribed the patients in the past. Now it is limited. Other areas of implementation is clinical trial in pharmacies, preliminary diagnosis that is done, or automated image processing, and obviously cyber security that is involved in health insurance. So these are multitude of implementation that has been done in our companies. I will not go in detail about each implementation. We have already seen that in the past in this one or two use cases that are I've explained. Mostly these are done with similar architecture. Okay, let's switch over our attention now towards non-healthcare implementation. Just as a time check, we are at 1 hour 10 minutes now. We'll spend around 20 minutes on two more use cases, and then we go right into the disadvantages or the precaution that we have to use for AI, and finally question answer session. Okay. Abhishek, as a moderator, do you have anything that you want to state before we move? We are going okay. Okay. So the fourth use case that I want to bring into your attention that we have implemented is about credit card fraud. A credit card fraud is where a credit card is being used by a person which is not the owner of that credit card. So, what is the approach that we want to use with this? So we define the objects which are the part of the use case, what is involved in the process. What is involved in the process is the transaction that the date and time of a transaction that happened, the account through which the transaction happened, the product that was purchased, the total value of the transaction that happened, where this was done, and demographic information. How this is important, I'll take an example. If a transaction has happened, for example, I live in Washington DC here, and then my credit card is swiped in Mexico, and I have never visited Mexico in my past stints or my in the past. Immediately credit card companies, what they do is, based on my past previous transactions that they see, they immediately alert this transaction and block credit card processing. It does not mean that that transaction is always fraud. I may go first time to Mexico and my credit card might get blocked, and this is the case we have seen in my European trip where I visited many countries. I have seen that my credit card was blocked when I swiped in, say, Switzerland or Italy or France. So person who is going first time has to call and pre-authorize, say that they are going that country, so that fraud alert is disabled. But in real cases, in some in most of the cases when that kind of fraud happen, the credit card companies use big data and AI to get alert and block it. Example another being product purchase. If a person is never ever interested in his past to buy any sports product, for example, and immediately a credit card company see any sports product, a high value sport product, for example, a golf club is being purchased, or anything related to golf is purchased which is high value, so that triggers an alert to them. Another uh, another entity that is tracked here is customer. what kind of customer it is, what kind of card they use, what is the limit that they have on their credit card, what is the expiry date, demography of the customer, segment they belong to, like uh, we divide customers in various segments: high, low, low, medium, and high, or we call that as a priority customer or a regular customer, etc. So these are the type of customer attributes that are tracked to ultimately block um, um, uh, 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 block the transactions. Give me a minute here. My Sorry, my external monitor got a problem. Okay, no worries. Okay, I'll do that. Are you able to see now? Okay. So in this case, what we do is we aggregate the historic data. We Okay. Let me see. Is it okay now? It's fine. Okay, very good. Sorry for that. Um, so as I explained, the attributes are all about various type of transactions and customer type, total value, what average they do, what average spend they do every month, what kind of merchant was there on which the card was swiped, what product was purchased, etc. Okay. Now, how this is implemented using Spark streaming technology. What we have done was data from various sources, particularly mobile, web, or custom app. Example: if you purchase any items using your mobile or your web, or say point of sale, all of the data sources from here are fed into stream queues. This topic A, B, or C are queues on which streaming kind of data comes in, and this is implemented using Spark streaming, which is fed into Cassandra storage using batch. All batch processing is on a Hadoop platform. And finally, user interface query web app. You can use any front end to get your alerts. Okay, but the idea was to how AI or big data come into play for this kind of use case. This is the data pipe that I want to show you. Here, the source system with high volume and massive read write is pushed to an enterprise scale using Kafka. Then a JSON files are transmitted to MuleSoft into Kafka platform. So the data pipe that you're seeing are numbered here, number 1, 2, 3 up to 5. Spark streaming captures the string of strings, stream of strings going into Cassandra, and finally SAP in memory using HANA platform. And Tableau dashboard was used to as a presentation layer for display. Okay. This is the high level reference architecture. This high level reference architecture is an IT architecture that talks about what big data infrastructure was used, what was the ingestion layer. So as you see, here are the various data sources. The data can be retrieved using transactional system or from Salesforce. You can use a social network example. People do buy things from Facebook connected applications, and then all that streaming then push into a data pipeline using this big data infrastructure. Uh, then it goes into a data lake where a model is optimized. AI platform is used to generate a model. It goes into the self-service environment for visualization. So self-service, mobile enabled, and Tableau reporting is done. So that's about the credit card use case that is used for fraud detection in a credit card companies. Let's talk about the last use case that I'm going to share about is marketing campaign, about B2B marketing. In this, I will be sharing with you about some of the deeper algorithm models using R and mathematical evaluations. So in this campaign, what is done is uh, it's a campaign done to identify the potential customers as what kind of products they are interested in, or what kind of products we can target to customers. So the campaign is done using some channels. Those channels are called behavioral. Those channels will capture the behavior events or conversion events, whether the the potential customer was able to be converted, or a potential lead was able to be converted into a customer or not. Okay. um, the path is a customer ID, meaning that customer ID is tracked all the way till the last stage of conversion, both positive path and negative path. Each path is a record, both positive and negative, as we label it as outcome. R is used for the attribution model, the language R. The probabilities of the transition we capture from one state to other state as we move into the channels. We estimate every channel and touch point. We then provide the weightage to all the channels. Regression logistic is used using Spark. And finally, the budget allocation and attribution model. So I'll take this example. This was exactly implemented what you're seeing here. So the channels, there are three channels as I mentioned you: email, web search, and direct channel. So these are called C1, C2, and C3. So when a customer is targeted, you start and say 60% of the customer, we send a campaign to 60% customer using email. And then 40% customer we send through web, or they did a web search. Out of the 60%, 33% of them did not proceed. That means it ended into null. This is called negative, or as we said, negative label. They end into the end stage. 67.33, after getting an email, they went into web to do a search. So they went from stage 1 into stage 2. Now, out of these people who came here, 100% of them from web search went into a direct website. Direct channel means they are buying directly from a company's website. So they went into a company's website to buy direct, and then out of 60 of them again went into a negative or a no result stage where they stopped buying, but 40% got converted. That is, we converted 40% out of this 100% that came on their website as a customer. So this what you see here is exactly the AI implementation, and it's called Markov channel distribution. These kind of implementation are done using AI algorithm, and those AI algorithm, the approach we used was using Spark and Hadoop again. Thoroughly in step one, thoroughly the data sources were mined to define what are the key predictor variables for the desired customer. What how they proceed from stage one to stage two. So that information is retrieved. Then a modeling framework such as finite mixture regression, FMR models, collaborative filtering model. These are the two models that are considered to act upon the data sets and to act upon the customer profile to generate the marketing mix. In step two, what is done in step two is to estimate the customer product propensity. Customer product propensity simply means that how a product is is sellable to that customer, how or what percentage of the customers are interested on what kind of products. So that build results in an enriched attribution model. Finally, regression and neural network were used to build a predictive models that estimates the product propensity based on extracted features on text mining. In stage 3, digital behaviors are then used to create prescriptive actions, extract other features that could predict customers' response rates, and finally develop a predictive model that estimate each customer's propensity. Okay, now that results that kind of implementation also results in one different kind of use case, which is called predictive model cross-sell and upsell. In this, what is done is a deeper insight into customers' propensity to buy a product is done. This should incorporate all the customer prospect touch points, firmographic data, product features, customer product features, and product portfolio for existing customers. Now, there are 3 bullet points here that are defined. How this is done is these are correlation of population disease. This is done in population health management, as we discussed in previous slide. Consumers product, cross-sell and upsell, and user movies recommendation. Example being Netflix and Amazon Prime. Those are the cross-sell and upsell predictive models that they use for a customer, as customer will go and buy what kind of movies. That's about 5 different use cases that I took today based on different implementations that I have done in past decade. I hope this will provide you the variety of implementations on different verticals like healthcare, retail. I took finance. So those kind of industries, how big data and AI are being incorporated, how AI is incorporated using big data. This brings me to, we are right at 12 o'clock here at midnight in US timing, and we are going at a right pace. I want to pause here and give you some opportunity to go ahead and please document your questions for the five different use cases that we discussed. If you have any of those questions, please document that on the chat window or note down on your notebooks. We will be able to take those questions during the last 30 minutes of the session. So I will go back slightly to the slides and I'll browse slowly, and you can review them again and take notes and write your questions. The first was about subscriber risk scoring done in health insurance sector. Health scoring defines it reduces the cost of healthcare, and also, and for member it gives an indication that how good or bad their health is and how much focus they need to give to their health. Second is about hospital readmissions. This is for the regulatory and compliance need, that readmission should be avoided, and we discussed about these various techniques that are used: Python libraries, feature scaling, models that are used in readmissions, and the infrastructure and high level architecture that we have used in this. The third use case was about mammography. Kaiser Permanente was involved deeply into this to avoid false positive and to avoid the members coming back for false positive screenings. 1,100 scientists were involved in the project. 144,000 screenings, mammogram image was taken. 80,000 people sample set was there for this. Ultimately, resulted in cost reduction for the tests that might have performed. Different multitude of implementation in healthcare industry. Credit card fault analysis, fraud analysis, and finally about campaign analytics. Okay, so these are the 5 that we took. Let's go on the last section of today's presentation, and that is about hidden risk of AI and big data. Now, when we talk about hidden risk, what it really means is AI and big data are not always advantageous or better and good solution to use in all the cases. The AI and big data need to be used in a very careful manner. The customer or the implementation consultant should be aware of what tools, technologies, and concepts they are implementing and for what purpose. So, having said that, we know that AI is very good in finding patterns and relationship for a big data sets, and however, it is still not very intelligent like a human brain. Crunching the number can effectively identify and find subtle patterns in our data, but it cannot directly tell us at what are the correlations that it is giving to us are meaningful or not. There is a concept that is called correlation does not imply causation. This concept really means is it is an ability to legitimately deduce a cause and effect relationship. So when there are 2 events or a variable on the event, then 2 events or variables solely on the basis of observed association or correlation may not be right. It is important that the correlation need to have an implied causation, meaning this is an example of questionable cause. Uh, if there is a cause and effect, then sometimes that is a questionable that need to be answered, and that result in a logical fallacy. A logical fallacy simply means that there are 2 events occurring together, but there is no implied cause and effect relationship. I will like to give you an example on this. So let's take this interesting example. So in the first graph that you see, this is a data correlation model in a data set that says, hey, sale of ice cream increases because with forest fires. Really? Does a forest fire, impact sale of ice cream, or do we need to do forest fire to increase the sales of ice cream? Second example is similar to that. That ice cream sales have been observed to increase when there is a shark attacks on beaches. So what is the correlation? And this kind of correlation in AI and big data is problematic. What essentially any layman or a novice person using AI will do is they will generate a model, and they will generate model based on this direct relationship. However, they have not thought about that the causation impact here. In both the cases, the causation impact was a third factor which is invisible here, which is good hot weather. In good hot weather, people go to beaches, and because they go to beaches, obviously they are prone to shark attacks. And because of hot weather, they also purchase ice creams. So both hot weather is the factor that is common, which is invisible in this correlationship. And that is the danger of AI and big data. That the third factor, which is what we sometimes call that as a spurious relationship, is not visible. Another example of the same concept. This was done in 1949, where the cases of polio was plotted against the sale of ice cream. Again, the same concept. It has a direct correlation. If you see here, the graph are exactly going along with each other. The sale of ice cream increases, the polio increases. Does it mean that ice cream is bad or it can result in polio? So there was a discussion, or I will say that argument that happened in mid 1950s, that the ice cream should be banned, or they are actually put that as an anti-polio diet. Fortunately, those scientists came to know that there is a relationship between polio and ice creams, but only during summer, because they know that during summer the polio outbreak happened. The polio outbreak did not happen in winters. So that's the hidden factor, which is the hot temperature or the warm weather. That's the danger of doing a data-based AI using big data, not doing an information-based AI. And I'm going to discuss that in next slide about that. What is data-based AI versus information-based AI? So in real statistics, a spurious relationship or a spurious correlation is just a mathematical relationship in which two or more events or variables are associated, but they are not causally related due to either a third factor or an unseen factor. And that unseen factor is sometimes called as lurking variable or confounding variable or a common response variable. So an example of such lurking variable could be the same correlationship that we talked in previous slide is ice cream and shark sales. Okay. So that's the danger that I was talking to, and that's where the limitations of AI and big data come into play. Now, what happened was, with enough data and enough computing power, the statistical algorithm patterns can be found. We know that. But are these patterns of any interest? Are these patterns that are generated are of any value? Previous example that we took, polio versus ice cream, right? So even if we supply, billions of data points with that data, not all of them are important, and sometimes that result in spurious patterns, and that could easily outnumber the meaningful one. Big data combined with algorithm can be an extremely useful tool when applied correctly. The underlying point here is applied correctly to the right problem. So you should always start your analysis based on an underlying understanding of the problem that we are trying to solve. We cannot blindly put any data set that we collect, and then put AI on top of that. It is an important thing that we understand what is the correlation between those patterns, and if any pattern is spurious or not. The uh, another problem with larger data set is, it brings a larger noise also. So sometimes when we collect the large data set and when the data sets grow, arbitrary combinations of correlations are identified in that large data set. These arbitrary correlation are because it's so much data that data sometimes itself, that noise outnumber that real data. Unfortunately, too much information tend to behave like very little. Very important point, where we say that in this case the noise outnumbered our information, and hence our data now become with a very little information. So that is useless information now for our AI and big data solution. The last and the final touch point here is we should always add information inside our model rather than adding the data. What it means is all of our and all of my career for last 20 plus years, in the beginning, first decade, we were always talking about data analysis, data analytics, reporting using data, etc. There was no mention about how information analytics can be done or information usage is there. So with AI and big data, now this has become more important, that we should focus more on to add information rather than the data. The risk of adding data is that it contains misinformation, as we discussed in the previous 2 points, and finally can downgrade the performance of our models. So this culminates the with this we understand that the AI or big data should be used in a cautious fashion and cannot be implemented blindly in corporate sector or enterprises just by using tools. There is a limitation of having tools versus limitation of having a good set of data and good set of eye with having right correlation. So if I am showing you here the architecture landscape, this architecture landscape is available at various AI implementations site on various companies. But what the challenge every company is facing right now is availability of a subject matter expert in their company to identify spurious relationship between the attributes that they give us. It's very important that the model that is refined using the data lake or any data that we supply, that model generate the right data set for the future, or it generate the right relationship and correlationship for the future. Okay, this brings the end point towards my presentation today. I hope this was useful to you, and I will open the forum now for any open questions that you may have. Abhishek, if we want to take a break, we can take a break for 5 minutes and then can we get started, or we want to continue? It's your choice. Okay. Let's take a 5 minute break for as a bio break. If anybody want to go, I will also take just a water and I will resume back. Okay. Thank you. Let me know when we want to get started if everyone is okay. Okay. And Abhishek, I want you to, if there are any questions on the chat, I want you to speak that out so we can answer those. Uh, Abhishek, can you also unmute my colleague Ravindra Shukla? You can unmute both video and audio for him so he can participate in that.
Now he has access.
Okay. Ravindra, are you here? Can you hear me? Ravindra Shukla, can you hear me? I think Abhishek is still on mute.
I have allowed him to unmute. I guess he will have to unmute himself. I cannot unmute anyone from my side. They will have to unmute themselves.
Okay. Ravindra, can you please unmute yourself?
Okay, can you hear me now, Manoj?
Yes, we can hear you loud and clear.
Okay, great. So yeah, fine. I can hear you now.
Okay.
Great. So,
Yes.
first question is from one of the participants. He's asking that how can a statistics graduate move ahead in the field of data science and AI? What is the necessary knowledge required to start their career in this?
Um, as I hear, because your voice was intermittently breaking, what I heard from you is how statistics is an important field in AI and analytics or algorithm. Is that the right question? How and what statistics knowledge can do?
So it is slightly on more focus towards the career part. So,
Okay.
how a statistics graduate can like move ahead in this field?
Very, very good question. I can answer that. See, the people who are from a statistics background, who have done masters or a graduation on a statistics, they are very much required or wanted nowadays in AI modeling arena. All the models, different modeling technique that I showed you, they are all being governed and driven by statisticians. The statistician, what you learn in graduation or post graduation, as we have learned in engineering and masters as well, these are pure. This is pure mathematics. This data science, machine learning, and artificial intelligence is driven by pure statistics and mathematics based science. So very much desired qualification for this area. You can supplement this about your statistics knowledge with with some of the statistical tools that are available in the market in IT world that will help you advance your career. So along with statistical graduation, if you can take any of a training or a certification course in the IT for big data or AI, that will supplement and help your career advancement. I hope that answers your question.
The next question is what is or how can we explain product propensity? That is the word.
Sure. I will like Ravindra to take that. If
Yeah, sure, Manoj. So yeah, so good morning, everybody. Yeah, so this is again Ravindra Shukla, and I'm very happy to have an open discussion with you guys on the AI and big data. So product propensity, if you are like, what is exactly happening? So in data science, well, every basically feature, every object is represented by n number of attribute. Okay, so let's say you are talking about a product. Product might have a shape, it might have a color, it might have its capability. So you derive the feature. You have a lot of like attribute. Those are nothing but the feature of the object. You represent them using like your numeric basically dimensions. So what really happens when you, let's say you are defining like one product, it's got like 10 different like features, and for every feature you have like number. Your number can range from like say 0 to 1, like let's say 0.5, zero point 0.2, whatever. So if you are talking like another product which is got very similar dimension, basically similar attribute. Think about you are drawing a like basically n dimension like a vector in a space, and then if the two vectors are very close to each other, they are going to they are going to have a very similar functionality, similar attribute. So product propensity is nothing but you try to define the attribute which defines that product, and then depending on those attributes you can understand how close those two basically product are to each other. In that way basically you can correlate if user A likes let's say product B, and then user like X like also like let's say another set of product, and if like user A and B has got a similar propensity, there's a good chance they are going to like the similar product. It's a it's a yeah. So is it clear, or you have any other question?
Swati, does that answer your question, or if you want something to be added into that?
Yes, clear. Thank you, sir.
Yeah, propensity, you can think of English word as closeness to each other. That's it.
Thank you.
Yes, sure.
Manoj, before we proceed, can you like stop sharing your screen because now we are seeing two Manoj and two Ravi. Thank you.
Is
Thank
that
you.
okay? Yep.
So the next question is from S. Bala Subramanian, and his question is: can you tell me statistical tool utilized in stock exchanges?
So
So, you want to take that?
yes, yes. So statistic. So normally stock exchanges, which are financial industry in nature, as I explained you, we have variety of tools, and variety of tools means these are, so two things you need to understand. One is algorithm, and second is tools and technologies. So tools and technologies, same tools and technologies, like when we say Hadoop, it's a platform, it's an infrastructure. It has multiple tools inside it, tools for data acquisition, that to retrieve the data, tools for data processing, tools for data display, which is presentation layer, tools for performing the analytical functions, like, you know, to generate a model, etc. So that those are the tools that are used in common to various industries. And I showed you the diagram for healthcare, health insurance. Those are the common tools that are used. Now, it all depends upon the right use of algorithms that may be suitable for finance industry versus healthcare insurance industry. So it's the algorithm that will define which is suitable for one particular industry. So I will like on algorithm side, if Ravindra can touch upon this slightly, as what is the difference between finance industry versus healthcare industry in terms of tools, techniques, and an algorithm here, and particularly on stock exchange, Ravindra.
Yeah, so basically, no, I think Manoj, you touched on the right area. Basically, what really happens, you have a set of e platform how to manage the data and how to analyze, and you have a set of algorithm how to apply those algorithm on top of data, and then like how do we make the prediction, or how you like want to prescribe the next set of action. So the logic, so the data science logic can be applied in the healthcare, in life science, where you can have a better like way to design the drug, or better way to predict the stock market fluctuation. So let's talk about, so for example, what is exactly difference between the financial industry versus healthcare. So healthcare, what is really happening? There may be see many time for wow, as we discussed in the beginning, it's very important to collect the right data, relevant data. See the you can always make the model to learn based on your data. You need to define your right set of input variable, right set of like what is the independent variable. So the way you model the problem in healthcare is very different the way you are going to model in financial industry. In healthcare, let's say you are talking about you have the patient data. Some patient is coming, you got like his biometric reading, he's got his lab result, but there may be like another 10 information which may not have factored, which may not have captured for that particular patient, and they may not be known. So healthcare industry, life science industry becomes much more difficult in the sense there may be many unknown areas and they might be impacting your prediction in bigger way. Finance industry, what happens? Similar situation can apply there also. For like for a market to grow, for economy to do better, there are multiple factors. There can be social political scenario in the world. It's not just the job market, not just the growth, not about your GDP, not about like how like the economical factor are doing, but the social stability is also related. What is happening in Asia, where population is growing, where more people are coming into job market, might also impact what is happening in the US. So we just need to understand when we try to simulate basically what is data. You have n number of data you are trying to simulate how these sets, how set A is going to behave, and then how we can try to find the correlation between set B. So it's all about trying to define your boundary condition, trying to define your dimension, trying to define the dependency and correlation between these different elements, so that you can try to be as close as to the reality. And that is where I will say, like, finance industry uh, have a very similar challenge, like very similar to life science and like healthcare, because many time you may not see, many time why do we need SME feedback in our modeling? Because we need to we want to map the data point to the actual scenario as close as they can be, and that only comes with the experience. Many time in fact we learn based on the data, and then we go and like refine our input model. That is why data science is also called iterative method. So platform wise logic, again, life science in this, the finance industry deal with a huge amount of data, the big data, and then columnar storage all is originated from more there. All this anomaly detection, the way we are going to solve might be very different than the time series problem we are going to solve. So it's a tool platform will remain same. It's just about the simulation and the logic we want to use. They will differ industry to industry.
So I want to add one point here, Ravinder. So the responder who has asked the question, if you specifically ask what are the most important tool sets, I will say that for modeling, and if you're trying to learn and implement, Python has a libraries for many verticals. So you use Python. R language R also is very much used. So Python and R has libraries that you can use. And for data acquisition and all that, you go on a big data platform, use Hadoop, SDFS, Hive, and NoSQL. You can use Cassandra. So those are present in my PowerPoint deck that I'm going to share with you. You can use those in financial industry as well as is. So the architecture that are defined in various use cases that I have, that can be easily and rightly implemented in financial also. Does that answer the question?
Yes.
Okay.
So the next
We
question
can move to the
again
next one.
from Miss Bharti, and the question I'm not very sure that what she wants to ask, so I will ask her to clarify. So the question is that any suggestions on how to introduce data for engineers? Sorry, not engineers, for teenagers. How to introduce data for teenagers? So, ma'am, I would request you, can you clarify on your question a bit more? So,
Yeah, good morning, sir. Actually, data science is the latest thing CBSE has introduced recently for the school student. So I want, do you have any suggestion like how we should introduce and what they can explore using the net?
Sure. So the basis of data science are two things. As you have seen in one of my presentation, that data science involves AI, machine learning, deep learning, etc. Right? So my son is also in a high school right now. The very first step that you do and try to understand is how to use the data science libraries. And in order to use those data science library for modeling is to understand Python. Python learning is the first step to do. If you are a high school student, I'll recommend that you take a course of a Python to start with. My son, which is 11th grader right now, he's learning Python, and he will move on to data science very quickly. After that, when you are well versed of Python, because Python now enables you to use the tool, not only tools, but use the algorithms which are open source software, open source libraries for the modeling techniques that were defined. Second step to do to learn big data and AI is to understand the concept of big data analytics. So you can take any coursework that is there on online platform using Udemy or Coursera. Those coursework are for big data. you can take that big data and then move on to on the AI side. That those coursework are just 40 hours coursework that they teach you how big data platforms are structured, and then you will understand how they can use in AI applications. So this is a three-step process: learn Python, learn big data, and then learn AI, particularly writing algorithms and those things. You don't need to write as such now. Nowadays, the entire industry is going on a method where open source sharing methodology is there. So many people have already developed reusable algorithm that you can always use. So go for Python first as a high school student, and then go for big data course, and after that you will be well versed to go into AI. Does that answer your question?
Thank you. Yeah, thank you, sir. We have introduced Python 9 onwards, 9, 10, 11, 12, 4 classes.
Very good.
So already,
Now, if you know Python, then you can start searching for AI libraries. And in my presentation, I have a Python library that I have given you. You can
yeah,
talk to your instructor or your teacher there, and then
yeah.
ask how to use these libraries in Python.
Thank you
Okay.
very much. Yeah, thanks.
So Manoj, I do not have any questions in pipeline now. So if any of the participants have any more questions, you can ask yourself. Maybe you can post again and I'll ask.
Okay. So if there are no more questions, I want to take this opportunity to thank everyone who have participated in today's presentation. I hope this will bring a value to your learning skill sets or your focused area that you're trying to gain. At any point in time, if you have any questions after this meeting, in the presentation, there is an email ID that I have shared. You can send me an email, and we will be glad to connect with you via Department of Computer Science, MBM Engineering College faculty, and we can go from there. Any questions regarding any BI, ML, or deep learning, my colleague Ravinder Shukla will also be able to give you attention. I'll share his contact as well with Abhishek, who can distribute that.
Thank you. Thank you, sir.
Abhishek, any closing notes that you want to give before we close?
Sir, as a tradition over the last 5 days, what we do is, for the sake of memories, we take a picture. So it is not a picture actually; it will be a screenshot. But we would like to like have that opportunity to take that picture with our speakers. If that is okay with you, I'll request the participants to unlock their cameras or turn on their cameras. After that, we'll be doing the closing.
Abhishek, can you introduce who are current faculties in the MBM? I just want to say hi to them. Um, who are currently assistant professor, associate professor, or professor in our
Right
engineering
now,
college. In
right now,
currently, if you can introduce them.
yes, sir. Right now in the teams, actually, we have only one other faculty apart from me from computer science. She's Sangeeta Kumari ma'am. She has been associated with us as assistant professor for last 3 years. And other than that, there are some people who are connected through YouTube, so they are not on MS Teams.
Okay, thank you. Hello, Sangeeta. Thank you attending the session here.
Hello, sir. It was very nice session. Thank you.
You're welcome. We have been part of MBM alumni. I was the fourth batch that graduated from MBM. We started in 1994 as the first batch.